All right. Good morning, everyone. I'm excited to be here. Well, customer interest in using open source software for observability continues to grow. They love using open source software because of the flexibility it offers in customization or the ability that they have in integrating with other open source software that they love and operate in their environments. And also the fact that they can stay vendor neutral and live at the edge of innovation that happens in the open source world is really very exciting. But at the same time, when we talk to customers, they always express concerns about how difficult it is for them to operate the underlying infrastructure to support the open source software. It is extremely difficult to operate a highly available, resilient infrastructure at the same time that is cost efficient. That is where AWS managed open source observability services can come into play. My name is Imayakumar Jagannathan. I'm a principal solution architect at AWS. And in the first part of the session, I'm going to talk about some real-world use cases, and we discuss about details on some customers that face some certain issues or in their observability challenges, and what kind of decisions they made and how they choose open source software to solve their problems. And then Gustavo Franco from VTEX will talk about VTEX's journey into using AWS managed open source services to solve their observability needs. Then Mark Chenet will talk about we'll give some insights into how we operate these services at large scale, and also give some insights into some new features and launches that we launched recently. All right, so before we move forward, I want to set the stage and make sure everybody's on the same page on what observability is and what the topic that we're talking about. This term originates from control theory, right? So essentially, a system is defined to be observable when you're able to infer the internal state of the system by looking at the external symptoms or the signals it is producing. In software engineering or computer science, you can relate this to being able to identify the root cause of an issue that you're troubleshooting in an application by looking at the signals or the symptoms that you're able to look at externally. Then you might ask, okay, so what exactly is monitoring, right? So monitoring is essentially the overall actions that you're performing, whereas observability is about building those systems so you can identify and correlate signals that are captured from the application so you can troubleshoot quickly. The signals that we're talking about are primarily metrics, logs, and traces. Metrics are the best way for you to understand or get a quick view of what is happening in your environment, and that helps you visualize an application, particular parameter like CPU utilization or memory utilization or anything like that. You can visualize it. You can get a quick insight into what exactly is happening. You can alert and so on. You can compare a particular situation, identify patterns, do anomaly detection, and so on. It makes it very easy and also very cost efficient. You will go to logs when you want to dive deep into a particular context of the application. You want to do more analysis and find out the root cause, and that's mostly done after you get an alert that is essentially most of the time set on metrics. With microservice architectures becoming so common, it is very normal for customers to start looking at how can I capture signals that is across service and process boundaries, right? That's where traces comes into play. Traces help you understand service-to-service interactions at the application layer, gives you information about your service latency, your service errors, faults, exceptions, et cetera. And by looking at a service map, which basically is a real-time representation of how your microservice architecture is performing, you can very easily find out which particular service is causing a specific problem, so you only need to dive into that particular service to understand or find the root cause and fix that issue. At AWS, we believe in giving options for customers to pick and choose the kind of services that they want so they can build the most optimal architecture that really works for them. On the left-hand side, you see AWS native observability services with CloudWatch and X-Ray primarily. With container insights, Lambda insights, contributor insights, and application insights, you can choose specific purpose-built features for your specific use cases. For example, using CloudWatch synthetics, you can build canaries to test your applications from customers' point of view and find faults and issues and errors in your websites and APIs even before your customers come and tell you that there is a problem. Or real user monitoring or CloudWatch RUM will help you understand or capture information from customers' experience in actually using your application itself. It'll give you information about page load issues or navigational issues or any kind of user experience problems that help you understand how your customers are using your application. You can use that information to inform your user experience designers, your service API designers, and so on. On the right-hand side, you see open source managed services from AWS with Amazon Managed Grafana, Amazon Managed Service for Prometheus, and Amazon OpenSearch Service. It's really not this or that option. Customers really can pick and choose any combination they want. We have customers that use both AWS native services and open source-based services and really build architecture that really works for them. You can collect data from any environment and send to any of these services using any of these agents, using CloudWatch Agent or FluentBit or a Data Prepper, AWS Distro for OpenTelemetry Collector, and so on. And it doesn't matter what environment or where you're operating either. So it could be AWS, it could be on-prem, it could be your laptop, anywhere. You can collect all the data from anywhere you want sent to AWS services. First, let's talk about AWS Distro for OpenTelemetry. First of all, OpenTelemetry itself is very exciting for customers simply because of the breadth of tooling that it provides. What I mean by that is it can support any source to any destination. You can collect data from anywhere and send to any destination that you want. And you can also process the signals in memory. That basically means you can add additional context, you can redact information that you don't need, and you can aggregate, you can correlate, you can pass on additional metadata, enrich the signals. That basically means that helps you capture really meaningful information that helps you troubleshoot later on when you are working with the data itself. All of that is open source, and all of that can happen in a single binary or a collector called the OpenTelemetry Collector. Makes it even more exciting for customers. The AWS distro for OpenTelemetry is essentially a redistribution of the upstream OpenTelemetry project. Every single line of code that we write goes to the upstream CNCF project. And what we do is we pick some of the important receivers, exporters, processors, extensions that are components of the OpenTelemetry Collector, and have that go through our AppSec review process and make sure that it actually is doing what it is doing, and redistribute it to customers. And all of this components that we pick is based on direct feedback that we get from customers, right? And when customers use the ADOT Collector, they also get AWS support. So they have the peace of mind that they're actually using an enterprise-grade product, and they have someone to rely on when something goes wrong. We also support Java, JavaScript, Python, .NET languages as well. We'll talk quickly about the Managed Prometheus service. Prometheus is a very popular metric monitoring solution. Everybody knows about that, and people love to use PromQL because of the flexibility it offers and how easy it is to deal with high cardinality metric situations and so on. However, it is also a common knowledge that it is extremely hard to operate a highly available Prometheus environment. And it is difficult to provide high availability, resiliency, and long-term storage, and all that stuff. It becomes very challenging, that too at scale. That's where Amazon Managed Service for Prometheus comes into play. This is a fully serverless solution where customers really don't have to worry about capacity or availability or anything like that, and they only pay for what they're using. And it doesn't matter where your metrics are originating. If it could be AWS, it could be on-prem, it could be other cloud service providers. It doesn't matter. You can consolidate all the metrics into one specific area or one particular space called workspace. And you can query all of that, right? So it makes it very easy for customers. Then you have Amazon OpenSearch service. OpenSearch is a fully open source and analytics engine for use cases such as log analytics, real-time application monitoring, and clickstream analytics, right? The OpenSearch service is a managed service that makes it easy for you to operate the OpenSearch software on AWS. This service provisions all the resources that your OpenSearch clusters need, and also at the same time identifies faulty nodes in your OpenSearch cluster and replaces automatically. Right? It's handled. That's why it's the managed OpenSearch service. Then we have Amazon Managed Grafana, which is essentially the visualization layer of this OpenSearch or open source stack. But this is a fully managed Grafana environment that allows you to, again, not worry about infrastructure or anything like that. You get all the goodness of Grafana while getting all the benefits and advantages of it. It already comes with enterprise-grade plugins, and it comes with opportunities for you to have the AWS data sources if you want, or the third-party data sources, et cetera, and really not have to worry about the underlying infrastructure or availability because we take care of that. All right, so now let's dive deep into the specific use cases that I've been talking about. The first one is about a customer who really wants to, who has modern workloads. But before that, as part of my role at AWS, right, I talk to hundreds of customers every year. And it gives me, it's a privilege for me to talk to these customers so closely and discuss with them about different problems and ideate about different solutions and services and help them design the architecture that would work best for them. But this particular customer that we've been working for a while, they are currently migrating their workloads to AWS. They are moving away from a SaaS-based observability software into open source observability solutions. And this customer is Fidelity. Fidelity is a privately owned financial services company that offers products and services for personal investing, brokerage, 401ks, institutional investing, and asset management. They have about 6,500 applications running on cloud. They operate about 1,400 AWS accounts today. And 60% of their applications in their entire portfolio runs on cloud. Right? Fidelity is still in the process of adopting to a fully open source managed observability stack. They are also particular about reducing their operational overhead by using managed open source observability stack or software or services wherever they can. They want to build a platform that is vendor neutral and also that leverages integrations to other aspects of Fidelity software or infrastructure that exists today. This is a simplified, high-level representation of Fidelity's observability architecture. Fidelity still has workloads running on on-prem environments. They have a small portion of workloads that are running on a third-party cloud service provider, but has a substantial presence on AWS. While they have a robust pipeline that is currently being built to handle different use cases, they have the tier 0 and tier 1 applications today that they operate. They are all designed in such a way that they have regional failover availability, right? So tier 0, tier 1 are really critical applications or mission critical applications that they want it to be available even if there is an issue with one of the regions that they operate. They want to design the observability architecture also to be very similar. So today they use the OpenTelemetry collector to collect metrics from their environments, and in a particular region, they send it to other regions as well, to at least one another region, at least for tier 1 and tier 0 applications, so they have high availability that way. And as a result, again, as I mentioned before, they're still in the process of rolling this out to production, but they were able to do some simulation testing in a pre-production environment. They found a lot of benefits, right? Found that they were able to easily scale for peak telemetry traffic while they achieved great flexibility in designing for signal collection pipelines. And they were able to set up a GitOps process, and which helped them automate the entire pipeline and deployment. They also were able to create design patterns for their observability pipelines for different teams based on their application criticality and different needs for that particular teams themselves. And this really helps them to onboard their applications to this pipeline very easily. Next, let's look at another customer who had traditional workloads, and they wanted to really move away from a self-hosted legacy software. They also had the requirement to monitor workloads in a hybrid environment. This customer is Phillips 66. So Phillips 66 is a global energy company with nearly 150 years of experience in the energy industry, and they depend on thousands of applications to run their business around the world. The applications run on a variety of environments, on AWS, on third-party cloud service provider, which is a smaller portion, but also they have a lot of workloads running on on-prem environments as well. They were using a legacy monitoring solution that really did not scale, that was not highly available, that was very difficult to operate at the same time. They are currently doing a lift and shift of their applications to AWS, and it's mainly EC2 based, as you can imagine. Their goals were to build a fully open source based observability stack and also try not to manage infrastructure themselves. And at the same time, they are very cautious about designing an architecture that doesn't make them end up being in the same situation they are in today, 5 years from now. Their primary goal, like I mentioned, is to collect metrics today because they're doing lift and shift. The applications are not completely modern, so it is very easy to collect metrics and logs. They use the ADOT collector in the on-prem environment, on the virtual machines and on-prem, and on the third-party cloud service providers' virtual machines and on EC2. They used EC2 service discovery mechanism to discover targets very easily. They deployed node exporters everywhere they can, so they were able to enrich the metrics that are being collected. And they added external labels to those metrics to easily identify the source of the environment that the metrics are coming from. And with that, they were able to create a single dashboard for all of these environments, on-prem, third-party cloud service providers, and AWS, into one Grafana dashboard. And they were able to go very quickly, filter and design, and look at what is happening at any given time. And there are about 200 users, I believe, that are using Grafana, this particular Grafana dashboards today for all of those environments. As a result, they achieved their goal of building this single platform for this. They just have one place to go. Doesn't matter where the metrics originate from, where the workload is running. They have one place to go. And they found that they were able to see 30% reduction in mean time to resolution as a result of deploying this architecture. Of these two, the one that stands out the most is what the customer said over a phone call like 2 weeks ago. They said that my teams come back and tell me that they were able to sleep better, which is such an important statement. When you have teams that are able to rest well, that basically means that they are productive in their work environment. They're able to focus most of their time into actually doing some mission-critical, business-critical operations than really focusing on operating the underlying infrastructure for observability tooling. They also have future plans to onboard SAP workloads into AWS, into the SAP workloads running on AWS into the same architecture, and also monitor Rancher clusters running on bare metal and in their virtual machines on-prem as well. So next use case is a very interesting one. This customer really has modern use cases. They have tracing enabled in all their environments, and their goal was to not only collect Prometheus metrics, but also extract metrics out of the trace data that they're collecting and alert based on that, right? This customer is Choice Hotels. Choice Hotels is one of the largest lodging franchises in the world, a challenger in the upscale segment and a leader in mid-scale and extended stay. They have more than 7,400 hotels all over the world with 625,000 rooms. They operate in 45 countries and territories with a diverse portfolio of 22 different brands. They are an AWS customer since 2014. They are all in on AWS, and they set a goal of migrating all of their applications to AWS by 2024, in 10 years time frame. They were actually using a third-party monitoring solution that really did not scale well, and that really did not fit the requirements that they have today of this particular goals in collecting the red metrics or request rate, error and duration metrics out of these traces. Again, they also wanted to build a open source based solution. At the same time, they also don't want to end up in a situation where they have additional infrastructure to manage. So they chose Managed Prometheus and Open Search Service for their use cases. That's how their architecture looks like. They collect metrics from and logs from EKS and EC2 instances, and they use the Lambda layer that we offer with the OpenTelemetry Lambda layer to collect the traces from there. What they did is they created a pipeline, a gateway pipeline in a separate AWS account, so they have separation of concerns that way. And again, there are multiple ways to solve this problem. This is how they decided to solve it. They used the upstream OTel gateway. That is because they wanted to use a specific component in the OpenTelemetry collector, which is not available in the ADOT collector today. It's called a span metrics connector. So span metrics connector, or connectors, in other words, are a new form of components in OpenTelemetry that are both receivers and exporters. They allow you to extract metrics from receivers and export that and send that to an exporter in the same collector that can be sent to a destination. So that is what they use to extract metrics from the span or trace data. They today use OpenSearch for logs. They still use Jaeger for their traces, but that is all self-managed. But as you know, these things continue to evolve, and they're considering evaluating the long-term fitness of Jaeger for the trace data storage and querying. Okay, as a result of deploying this architecture, they're able to collect 200 million active time series metrics from their environment. This is Prometheus metrics, from 5,000 EC2 instances and from 537 applications. Also, they found that they're able to do all of this by saving 40% on infrastructure, right? Which is basically checking all the boxes that they set to achieve in the beginning. The fourth and the final use case is about a customer who wanted to migrate from self-hosted Prometheus to a managed Prometheus environment because they simply were tired of monitoring and operating a large Prometheus environment themselves. This is a story of Northwestern Mutual, right? So Northwestern Mutual is the direct provider of individual life insurance in the United States. They were established in 1857, a Fortune 100 company with more than 4.9 million customers today. They are customers since 2014. They completed their migration to EKS in 2021. They're mainly their main goal is to containerize everything and throw it on EKS. That is their goal. And they have hundreds of AWS accounts. They have thousands of developers using more than 80 plus AWS services today. Well, with all of that infrastructure in place, Northwestern Mutual was not finding it very efficient to operate this large-scale Prometheus environment themselves. And so they decided to choose a service that provides them high availability, gives them long-term storage, and at the same time is resilient and that they can rely on. So that is the architecture they chose. It's obviously a very simplified architecture. And the reason why it's simplified is because I wanted to make sure that how easy it is for you to really replace your existing complex architecture to something very easy. All they did was they primarily focused on deploying the ADOT add-on that is available in EKS. I mentioned that most of their applications are container-based, so this is mainly the EKS use case here. And the operator add-on actually can manage the lifecycle of the OpenTelemetry collector for you, right? You could tell the operator to deploy it as the collector as a daemon set or sidecar or anything, and it will manage everything for you. So as a result, they achieved tremendous benefits. They found 50% savings in infrastructure costs. They were able to save half of 1 FTE time. They found that their metrics availability has increased significantly during firefights. And also, another most important thing, they saw 35% reduction in pages to their teams. That essentially translates to better work-life balance and lifestyle altogether. They also saw that their application teams were able to build pipelines so that their applications can be automatically loaded into this observability architecture that they built. Their MTTR, or mean time to resolve, reduced from 1 to 2 hours to just 10 to 30 minutes, right? So which is basically 75% reduction. The mean time to detect used to be 1 to 2 hours. That reduced to 10 minutes in most of the scenarios. So customers using open source services achieve tremendous benefits, right? In summary, this enables customers to attain higher efficiency, operate at a very large scale without worrying about infrastructure maintenance, provides them the freedom, the ability to integrate their solutions into other systems. All right, having said that, I'm going to invite Gustavo to talk about VTex's journey into using AWS.
Hi, everyone, and thanks, Imaya. I'm Gustavo Franco from VTex. And at VTex, I'm a senior director of engineering, and I'm primarily responsible for the subset of engineering and IT teams that work with many of our other teams to keep the company up and running 24/7. You might be wondering, what is VTex? VTex is the enterprise digital commerce platform. I like to explain to folks that we have the auto-update feature. We are a multi-tenant, composable SaaS platform where customers from all over the globe work with us to unify their order flow under a single pane of glass. Before we dig deep into observability and the VTAX observability journey, let me tell you a little bit about how technology at VTAX is organized. Technology at VTAX, or VTAX Tech, means the combination of engineering, product, and design teams. Development and production are a shared responsibility with the technical infrastructure team. And why am I telling you all of this? You probably realize at your day-to-day work, or some of you realize at your day-to-day work, that Cohen's law really applies. And if you're not familiar, it basically dictates that the system organization tends to mimic how you structure your teams. And we'll talk a little bit more about it as we progress in this presentation. What about the technical stack we're observing? When it comes to compute, there's quite a bit of Beanstalk, and we also use EKS heavily. And within Beanstalk, you're looking at C# as the primary language. And with EKS, it's mostly Node.js and Go. Networking, we have a fair use of ELB, and also we have our primary router, our application router that we wrote ourselves. And for data, we use RDS, S3, Redshift, and also several other AWS services are being observed. Let me tell you a little bit about the observability by the numbers at VTAX. You're looking at roughly 4 terabytes of logs per day, 150 million active time series, and 2 billion spans being ingested each day. How did the observability stack look before we work with AWS in our open search or open source-based journey with them? On the left-hand side, you can see apps or services, and those apps would generate telemetry or observability data and send it to a primary vendor and also to several other vendors. You can see them on the right-hand side. This posed several challenges, by the way. Let's talk a little bit about the observability challenges that we had with the legacy architecture. Observability budget was being overrun. We had lack of policy control and zero governance. There was a perception of a single vendor solution that was, in fact, a sprawl of shadow IT. And developers claimed the experience was good. Let's dig deep into each one of those. What do I mean by observability budget was being overrun? The investment in observability as a percentage of cloud investment was accelerating. It became a budget within the budget, which could be good, but the numbers did not look good in our case. And by reading social media, it seems to be fairly common of companies all sizes, possibly because of the next challenge I will discuss. So lack of policy control and zero central governance, right? Like, what does that mean? Product engineering teams, they could generate as much limited data as they wanted with direct export to third parties, nothing in between. And I'll make the call back to Cohen's law in a second, I promise. So no theoretical or technically enforced policies other than some data retention config was in place. So the perception of single vendor solution, what do I mean by that? The telemetry data was almost always exported to one primary vendor. And while it was in fact being exported to multiple other vendors with no clear criteria defined, right? So that's the key sentence here. The developers claimed that the legacy experience was good, and why that was. The primary vendor stayed with us for 5 years, so there was a ton of institutional knowledge about how to use that stack. How did we go about mitigating those challenges? There's a lot more than the technical side of it all here. I will cover mostly the technical in the slide. And we first decided by separating concerns. So there's a lot about that can be optimized when it comes to telemetry data generation. And processing, aggregation, sampling in the middle is for us a separate concern. And last but not least important, you talk about observability data and consumption as a third concern. So we separate those when we went about designing the new architecture. We also decided early on to go an open source first approach, but keep in mind that we would probably end up using 1 or 2 vendors in that journey or leveraging a partnership there with them. And why open source? Well, first, community. We want to leverage and contribute back to the community. We use a fair bit of open source at VTAX. And also, we had personnel familiarity with Prometheus and Grafana and similar systems. And also, we realized that the stack we want to observe integrated well with open source solutions. So then it was basically an all-hands-on-deck situation. Our efficiency improvement strategy was key to the company, and observability was a huge part of that. Here's how the new architecture looks like, just a high-level representation. On the left-hand side, you can see the applications. In the middle, we have the governance that we were seeking from the get-go, and we leverage OpenTelemetry collectors that we run ourselves on AWS. And the Cohen's law callback here, if you've been waiting, is that because we have now a technical infrastructure team in between, so that's exactly how we designed the system. And on the right-hand side, we have the data sync and visualizations with AWS or Amazon Open Search Service, Amazon Managed Service for Prometheus, and we also use another vendor for a tracing solution. It wasn't without its sets of shortcomings and mitigations, of course. Here are just a few examples of those. We had scalability issues in the beginning between collectors and data syncs, and that triggered observability data loss for us. So mitigation there was basically to keep a buffer between our collector or aggregation sampling filter infrastructure in the middle, and to weather any downstream issues, basically any data sync issues or issues between our OpenTelemetry collector infrastructure and AWS services. Also, our scale is not massive, but even though at our scale we realized that it was a good idea to go beyond a single open source service cluster and a single Amazon managed service for Prometheus workspace. One of each was not enough due to reliability concerns and even scale. How is it that we're doing today? Here's our scorecard. Our observability budget was being overrun. I told you this was a challenge. And I'm happy to report that well within budget, and AWS gives us more flexible billing options than we had with our previous primary vendor. I told you about the lack of policy control and zero central governance. That's been dealt with because we have this in-between or in-the-middle OpenTelemetry-based stack that is governed by technical infrastructure or SRE team. The perceived single vendor solution that was in fact a sprawl shadow IT that I mentioned earlier, and several teams working and using many different vendors on top or aside from the primary vendor now is down to a dual vendor solution. And last but also not least important, the developers claimed the experience was good. In parallel to the observability effort, we roll out a holistic voice of developer program. And this is an effort steered by our developer experience team. And what we discover is developers say it should be roughly the fourth in our list of priorities to continue to improve. But we realize there is quite a bit of, on the user experience side, that needs to be done for observability as well. We have a much better technical stack, but we can do quite a bit more when it comes to user experience for the developers. That's the feedback we're getting. So what's the plan ahead to address that and some other challenges still? Evaluate Amazon Managed Grafana to improve developer experience. It's something next in our list. Provide more VTAX-focused training. We gave more general observability training on the new tools, and now we're thinking to be more specific for VTAX use cases. We're also looking to ADOT to rebase some of the OpenTelemetry customizations that we apply ourselves. So as I mentioned earlier, in the middle of the stack, we have OpenTelemetry collectors that we're running, and we customize it quite a bit. And now we're looking to rebasing that with the open source community. And there is also quite some telemetry. So I mentioned earlier the split of concerns. And one thing that we didn't tackle head on first was cleaning up the telemetry data being generated by the applications. And that causes or triggers us to have to sample quite a lot. And we believe that by cleaning up the data or increasing the quality of telemetry data being generated, we can relax some of our sampling or aggregation rules, and that will also improve developer experience. All right, That's it for me, folks. And next, I'll call Mark, and he's going to tell you all about the features that I keep asking him for. Thank you.
Thank you, Gustavo. And there's a long list of features that you keep asking us for. So thank you for showing us another great use case around open source observability and your open source journey. My name is Mark Sheney. I lead product and engineering for our open source observability services at AWS, including Amazon Managed Service for Prometheus, Grafana, and AWS distro for OpenTelemetry. What I enjoy most about working at AWS is our customer obsession, and I see proof of this in a lot of these use cases that you see here. Our ability to scale at the scale at which we are operating, and third, our operational excellence. Our operational excellence is our commitment to building resilient, available software for our customers. And a lot of what I'm going to talk about today will show proofs of that and how we do this in terms of how we manage our own services. So let's talk about scale. To give you an appreciation of the scale since we've launched these services, only 2 years now since we've launched the services in general availability, we operate over 142 trillion, collect over 132 trillion metric samples across 14 different regions worldwide. In my session today, I'll talk to you about how we do monitoring and observability internally for one of my services, and I'll also share with you some of the new features that we're launching or that we've launched at re:Invent for some of these services. At AWS, builders are also operators. We run, scale, upgrade, and proactively remediate problems that impact our customers. As an engineer, you build it, you operate it. This DevOps culture is at the core of all the services and features that we build. I'm sure, who has talked to AWS support at any point when using an AWS service? Probably everyone. Our first responder engineers are the most critical point of contact to our customers. Maintaining a short time to respond to issues is very important as a service teams. At any point in time, they can escalate issues to our services. And it's important for us to make sure that they're properly educated, they understand how to run the services, they understand how the services are running, so they can quickly answer these questions that our customers have. We measure SLAs, we measure first time to response, and for me, most importantly, we measure the time that how many tickets actually get escalated to the service team. And for me, one of the goals that I have is always make sure that we maintain a less than 10% of the actual tickets that are being escalated to improve the overall support workflows for our customers. We have a primary and secondary on-call. The majority of our primary on-calls that deal with all the customer issues, deal with all the high severity tickets, have a one-day rotation, and our secondary on-calls are on one-week rotations. Moving to a one-day on-call has certainly helped with operator fatigue, reducing a lot of our tickets, and helping us overall creating a better work-life balance for our operators. But it's not the only thing that you need to do in terms of reducing some of these high severity or low severity tickets, right? Make sure that you properly categorize your tickets. Make sure that you also prioritize these things as part of your sprint planning and your quarterly planning activities. Proactive notification has different layers at AWS. We have aggressive alarms that monitor our P90, P99 values. We measure everything at AWS as part of our operational excellence. And we also have alarms based on failed canaries that automatically create AutoCut tickets for our operators. We then have an escalation management process. This escalation management process includes our ability to post when customers are being impacted to our personal health dashboards and our service health dashboards. This is an important aspect of being able to earn trust with customers because we want you to know if there's a degradation in the service and how quickly we are remediating that issue. That includes anything from an API error rate failures or an increased higher latency in some of our APIs. In terms of investigation and remediation process, as part of our operational excellence process, we monitor the request availability, latency, and error metrics that we have for all of our public APIs. The red metrics that Amaya was talking about, right? The request rate, errors, duration. This helps us measure availability and performance of all of our public APIs and our console. We also have global and regional dashboards that helps us monitor what's causing the most pain to our customers. We have meetings, weekly meetings within our teams to monitor these operational dashboards. But most importantly, there's also an AWS meeting that this happens, and you get on the wheel. And if you're lucky enough, you got to go present your operational dashboard across all the other AWS services. So you got to make sure that you're representing the right data on those dashboards. So let me tell you a little bit more about how we manage one of the services that I lead. So for Amazon Managed Service for Prometheus, we use a cell-based architecture. So a lot of the technologies that we build and the best practices that we have, we contribute back through some of these open source contributions, the blogs and article. Similarly to this cell-based architecture, if you're not familiar with cell-based architecture, please copy this QR code. Go have your teams learn about it. This is what we're using internally, right? We operate everything on native AWS for our service. In terms of our control plane, everything is serverless. We use Lambda and API Gateway as some of the services that we use. And we also use EKS Fargate as our cell-based router. And then in our data plane, we actually we use EKS to manage all our containerized environment. And these cell-based architecture create this isolation, reduces the blast radius across the region. You have multiple cells across different regions. So what about our tools, our monitoring and observability tools that we use? By a show of hands, who uses fewer than 2 monitoring tools in their environment? Fewer than 2, because I do want to go talk to you if you're only using 2. How about less than 5? Okay, what about more than 5? Few of them continue to grow. So for our Prometheus service, we use 5 collection services, and we also use 5 services where we store, query, and analyze observability data. And most importantly, we can visualize all of that data inside of Amazon Managed Grafana. Yes, that's right, we also use our open source managed services that I lead to be able to monitor all of these technologies to simplify that. So starting top down, for AWS Lambda, we use our cloud-native logging to send traces to CloudWatch logs, traces to X-ray. For Fargate, we also use our native logging capability for sending to CloudWatch logs. For EKS, we use FluentBit to filter logs locally before we send them to CloudWatch logs. And we also use, for metrics, we use some CloudWatch agent to be able to send some metrics to CloudWatch. But the majority of our metrics are all Prometheus metrics that we send to Amazon Managed Service for Prometheus. And as I mentioned, all the dashboards, or most of the dashboards and investigations by our engineers, are all done using managed Grafana. So let me share a couple lessons learned that we've learned while operating and deploying this infrastructure for monitoring and observability. So one of our leadership principles at AWS is frugality. So managing our observability costs for our infrastructure and for our observability is an important thing as part of our monthly activity for us. We scrutinize month-over-month cost for the infrastructure that we use and for the observability services that we use. One of my goals is to always maintain a cost for our observability tools less than 10%. Some of the ways that we improve our costs is some of the things that you may have heard through Adam's keynote. Some of the initiatives that were taking place right now is rolling out Graviton, which we are hopefully will be able to share with you next in terms of the improvements in terms of cost benefits and also performance benefits that we have. The other thing that you can take advantage of in terms of observability or logging, we've recently announced in CloudWatch logs a patterns command. The patterns command is used to automatically cluster logs with similar patterns, as you can imagine. And makes it very visual, it makes it easy to visualize the types of logs and the volumes of logs. You do have engineering that can get overzealous and try to log everything, info logs and production logs. That may work well in development, but when you get into production at scale, it creates a lot of logs that you may not need for investigation and diagnostics. So great opportunity to reduce some of the log costs. Everything fails all the time. Quote from Dr. Werner Vogel, Amazon CTO. That's one of the reasons why we use some of these Amazon managed services, open source services, and CloudWatch native services. But the services are only as good as the data that's being produced, right? If our agents go down, we're not going to get any visibility. So it's also important as part of your monitoring your monitors to make sure that you deploy your collectors into a high availability, in a high availability way. So that's something that we do for our EKS clusters. We always deploy our Prometheus collectors in high availability so that they can work independently and produce duplicate metrics, ultimately, to Amazon Managed Service for Prometheus, where Amazon Managed for Prometheus will automatically deduplicate all the metrics at no additional cost to us and to you, of course. We also monitor all of the logs and metrics from our agents, right, flu and bit, ADOT logs, to be able to monitor performance in case we have potential memory leaks or anything else so that we can recycle those components. As part of our service architecture that you saw in the previous slide, we use several AWS accounts to isolate functions per account. For example, we have 5+ accounts per cells. We have an account for a control plane, for data plane, for our canaries, for the console, and so forth. So CloudWatch usage metrics is an important thing that we even have to monitor as part of a service team. Usage metrics helps you monitor how close you are to your service limits, right? So things like a number of EC2 instances you have, number of auto-scaling groups you have. So it's very important to be able to detect and be able to forecast what you need in terms of those service quotas so that you can put in those requests through the service usage quota console or through a support ticket to be able to do that. So if you are not doing this already, I would certainly recommend to put those right alarms in place to go and monitor that. So we also publish a lot of different blogs and articles and documentation about observability practices. You can look at our AWS distro for OpenTelemetry documentation where we have a dedicated section around observability practices. Feel free to go look at those and provide some more feedback if you need some more information there and how to get started. In terms of how we deploy our services for monitoring Amazon Managed Service for Prometheus, we create one managed service for Prometheus workspace. A workspace is simply just an isolation of the metrics and the queries and the alarms, the rules that we have per region. So that one workspace per region will collect all of the EKS data that we collect for all the running containerized environments in one centralized workplace to make it easier for us to go and visually analyze the data. We also use CloudWatch cross-account observability. As I mentioned, 5 accounts per cell, some regional accounts, several cells in a region. You can easily see how you can get 50, 100+ accounts. And it gets very hard to understand where to go look for your vendor metrics, your CloudWatch logs. So by using CloudWatch cross-account observability, you can centralize a central monitoring account where you can get all of the metrics and logs in a centralized place to make it easier to query this data. So that leads into our third thing, naming conventions for data sources using Grafana. So for every data source that we use, we want to be able to simplify and leverage some of the strengths in Grafana for editing these dashboards and using template variables to quickly isolate and compare performance across CloudWatch data that we're consuming as well as Prometheus data that we consume. So to give you an example, for CloudWatch as an example, all of our data sources are prefixed with CW, dash, the environment, so beta, gamma, production, dash, the region name. And then sometimes we even go further, dash cell name as well, or cell ID. So that makes it a lot easier to take advantage of that, reuse a lot of the dashboards. And to give you an example of what that can look like, so this is a partial of one of our dashboards in our operational dashboards to monitor the alert manager. You see on top the stage, the region, and the vendor. And it's easy for us to compare across environments, across regions, what goes on into monitoring the health and performance of our, in this case, the alert management component. This is an example of a memory leak that we detected. Again, we contribute back. We use a lot of open source components. And we noticed that when we were deploying updates on the alert manager is a component as part of our Prometheus stack to be able to inhibit and route alerts to SNS, then you can go and route them wherever you want. And we noticed through the baking period, we noticed a slow memory leak, right? Everybody, I think, has probably had the chance of experiencing memory leaks. But ultimately, it's how quickly do you detect that memory leak, right? When you start operating at scale, as you start rolling out this change, so that one, roll back the change, number one, and then two, go remediate the problem. And that's exactly what we did. We were able to find the problem using a lot of Prometheus metrics And we also use continuous profiling data as well to be able to isolate exactly the code that was driving the memory leak. And we were able to then to roll back the updates to the alert manager and fix the problem, and you see the change that it had in terms of impact. Who uses open source technology? I hope everybody lifts their hand up. So this is an important part of what we do. That's one of the reasons why I built these services 3 years ago, was to continues to be thought leaders and good stewards in the open source community, really help our engineers in what we built, help contribute back to these projects. These are some of the projects that our teams and our sister teams in terms of like open source as well contribute back. And if you're looking to contribute to some project, if you've never done contributions to open source project, we'd love to welcome working with you. It's something that we do on an active basis. It's part of the career development of our engineers. And that's what they do, and you can see a lot of the contributions, like the alert manager that I was just talking about, and several other contributions. So if you're interested to learn more on how you can contribute upstream, or if you want to work upstream, please come and see me, and love to know how we can partner better on these areas. All right, so let me walk you through some of the new features that we have for our services that we've announced recently. So since we launched these services 2 years ago in general availability, we continue to improve our security and controls around the services, such as adding SOC compliance for both managed Prometheus and managed Grafana, also adding a bunch of certifications around security, ISO, PCI compliance for Prometheus as well. We've also added network access control for Grafana. So this allows you to control the inbound traffic that are coming to a specific workspace, to restrict it based on customer name prefixes, as well as VPC endpoints. We've also added secure connection to VPC data sources. I had to add that one back on the slide because I continue to get that question all the time. How can I connect to sensitive workloads that are running in my private VPCs? It's something that we've added like a year ago, right? It's an important feature if you want to monitor your RDS instances or your self-managed open source or any other self-managed data sources that you have. You can do this today with our managed Grafana instance. Scaling and region expansion is a continuous journey is what we do at AWS. We've recently announced at the beginning of the year 500 million active time series metrics per workspace and 30,000 rules per workspace. That's over a 20x improvement since we launched the service 2 years ago in general availability. Similarly, for Grafana, we support 10,000 provision users, 500 concurrent users, and over 2,000 dashboards and data sources. And we're continuing to improve on that based on customer asks. So continue to work with your account team or come and see us to figure out how we can improve those. So ultimately, right, this gives you the ability to monitor, billions of Prometheus metrics across all the regions we have, across all the different workspaces. Next, in terms of single pane of glass and unifying the experience, we're continuing to improve the experience between managed Grafana and managed Prometheus to be able to view all of these alarms that you have, these 30,000 alarms and plus, right, that you're managing, that are triggering, that you want to be able to silence. So creating a much better experience directly in managed Grafana to manage these scales of alarms. Managing cost, I think, how many times have we heard cost optimization in this session? We recently announced Amazon EKS multi-class cost monitoring. So this is an extension or an upgrade on top of what we had before. So through an EKS and KubeCost partnership that happened last year, we were supporting the ability to do cost monitoring for one cluster. In, I believe it was June of this year, we've added the ability to do this across all your clusters. So you can send all your cluster data to a centralized managed service for Prometheus Workspace to monitor all of your costs that are going on across all your clusters so that you can compare. We had a customer recently in the messaging space that said that within 10 minutes, they were able to deploy that to several clusters, and they were able to find $100,000 worth of saving opportunities around the utilization of their infrastructure. This will give you breakdown of cost by namespace, by pods, and everything else. Who has 10 minutes to spare to be able to go and test that out? Please come and tell me, give me some more feedback around that feature. Love to hear more about things that are working there. Open search tracing analytics. So this is the ability to use all of the traces that you're storing in OpenSearch and be able to use the same OpenSearch plugin to not only query and create analytics on top of your traces, but also correlate that with your logs that you're storing. And that also gives you the ability to correlate and be able to compare in a single dashboard your metrics as well that you're storing in Prometheus, or any other data source for that matter. Advanced sampling, so this is part of the AWS distro for OpenTelemetry. We've added advanced sampling, so the ability to group by, the ability to do tail-based sampling. We've also added support for Kafka, both as receivers and exporter components as part of our ADOT distribution. This was important because customers were using the Kafka as a telemetry bus, right? They want to be able to go filter, do better aggregation, so they wanted to be able to send things to Kafka, do some manipulation on the data, and then send it back to an ADOT so that you can then send it to a destination of choice. And then some other features that we've announced. Oh, I jumped ahead already. My punchline was gone. So as part of the serverless team that we were talking about, I was looking for some volunteers, actually. Who loves to manage agents, deploy agents, scale agents? How about making sure that you manage configuration drifts between all of your clusters and your accounts? I think any volunteers that want to help me out with that? I think no one loves to do that, right? Ultimately, one of the great things that we just announced at reInvent is a support for an agentless collector. So we will be able to discover and collect all of your Prometheus metrics inside of your EKS clusters and be able to securely do that and be able to do this based on however many endpoints that are available to be scraped and how many metrics you want to collect. So if you haven't tried that yet, I recommend you go on to try that. For those of you who continue to love to manage agent, feel free to do that. That's always an option with their ADOT collector. But this is certainly going to simplify some of the operator pain that may exist around managing and scaling and optimizing your infrastructure for collecting those metrics. Next up, 2 years ago we announced traces. Last year we announced metrics. And now working with and collaborating with the open source community, we've stabilized and now support logs. So now you can officially use ADOT, AWS distro for OpenTelemetry, to collect all three signals, metrics, logs, and traces, and be able to send them to destinations of choice. We've added and benchmarked and performance tested the log receiver, and we've also added support for CloudWatch logs exporter. You can also use the OpenMetric telemetry protocol, wire protocol, to be able to send data directly to OpenSearch as well. Next, Amazon Managed Grafana now supports up to 300 plus community plugin. That includes data sources, visualization plugin, not only the ability as an administrator to go and select these community plugins that you have access to through the community, but also be able to test the different versions. Go figure, right? Be able to test the different versions before you deploy it to your team, right? Make sure that they work with your dashboards. So we have full control over that inside of our managed Prometheus workspace. That was launched about, I think, a week ago. So what does this mean for us? So we had, 5 collectors, 5 different services. So some of the things that are going to change as part of our the things that we're testing out, baking now, and we're going to continue to evolve over 2024 for our managed services, is we're going to reduce the 5 collectors to 4. So using the ADOT collector for tracing and logs, and we're going to use our serverless feature, right, to be able to discover all Prometheus metrics from all our clusters. So really reducing some of that operator pain that we have in terms of managing these agents. We'll come back with questions. So during the session, we shared 4 great customer use cases and benefits for using some of these open source services. I also shared features recently announced for 3 of these open source observability services, including Amazon Managed Grafana for your rich data visualization, Amazon Managed Service for Prometheus for your high cardinality metrics, and AWS distro for OpenTelemetry for your instrumentation collection of all of your signals, metrics, traces, and logs. So what's next? If you're just getting started and you want to learn more about some of these observability services, check out these workshops, these best practices, these accelerators. It's a great opportunity for your teams to just start using them, start learning how you use and deploy these technologies. Come visit us. I will also be there tomorrow, but we're going to be at the Village. We can ask more questions about open source technologies that we have. And there's also some swag. Everybody needs more swag to carry home and check into your luggage. All right, thank you so much for